Hi Algebra 1, and with this video I just want to give you some quick tips on how to set up your homework and work through solving equations. This is obviously right from the beginning of our year together. This is chapter 1, this is solving equations. So first of all, let's talk about the paper. I like notebook paper that is college ruled, so the lines are a little bit smaller, which means you can get more work on the page. The first thing that would be great is to fold the paper in half vertically. So it looks like this. It creates kind of a line where half the page is. I mean, obviously I went over here, that's no big deal, but it just kind of gives you a stopping point. Next, I've highlighted the left margin. Don't write anything left of the margin except for when you number your problems. And when you number your problems, either circle them or put a big parenthesis beside it, just so you can see that that's just numbering the problems. And do number your problems. That's going to help you when we grade things and when you want to ask questions. The next thing, put your first and last name, put your block number, and put the date. Definitely date things that you have in your notebook. That's going to help you when you're trying to look back and find things to study for quizzes and tests. And I also have the section number. This is chapter 1, section 5, and then the section name right beside it. So when we're solving equations, one thing to keep in mind is that write the problem as it's given right from the book. Next, after that, the next thing I'm going to do is I am going to attempt to keep my equal signs lined up as I work down the page. And I'm going to continue to tell you guys that through the year. We're always working down the page, not to the right and up the side of the margin, but always work down. Try to keep those equal signs lined up. Now my equal sign is way over to the right. It's okay, but that's normally my goal, to keep the equal signs lined up. So what I think I'll even do here is I'll use this right-hand column to write my steps, the justifications of each of the steps as I work through this problem. So obviously this is what is given. So first step given. Next step, we need to combine like terms. I've got like terms on the left. So remember, it's the equal sign which differentiates the left-hand side from the right-hand side of the equation. So I'm going to do everything I can to simplify on the left, and that is going to be combining like terms. And normally, when I say combining like terms, I'm just going to say CLT. Now, there is usually a margin over here. I'm fine if you write all the way to the end of the page. That's why we cut it in half here. So we're combining like terms. A negative 5m plus 8m is 3m plus 2 equals 2m plus 11. So we just combined like terms. Now, if there had been like terms on the right, we could have also have combined them all at the same time. We're just trying to simplify before we start using the properties of equality, which we're going to do next. So make a plan. And normally the plan is, let's try to get all of our terms that have a variable on the left, and if we do not have a variable, just constants on the right. So let's start by using the subtraction property of equality, and we'll just call that SPOE, and we're going to subtract 2 from both sides. Remember, we're keeping our equation balanced by doing exactly the same operation to both the left-hand side and the right-hand side. So 2 minus 2 cancels. It leaves us with 3m equals 2m plus 11 minus 2 is 9. And we are going to do the SP of E one more time by subtracting 2m from both sides. The 2m's cancel. 3m minus 2m leaves m. M equals 9. So Now we're solved. We can do a quick check by taking our answer and plugging it back in to the given equation. So we can do that right here. -5 times m plus 2 plus 8 times 9 equals 2 times 9 plus 11. So that's going to be -45. I'm just using order of operations here. 8 times 9 is 72. 2 times 9 is 18 plus 11. -45 plus 72 is the same thing as 72 minus 45. So 72 minus 45, what is that? I'm going to come up here and check just to be sure because I want to be thorough. So that is 27. So -45 plus 72 is 27 plus 2. Is that equal to 18 plus 11? Yep, that is 29 equals 29. So 29 equals 29. There's our check. Just trying to conserve a little room here. So that's number one with my properties justifying each step. Number two, there's the given problem. Once again, I'm going to attempt to line up my equal signs as I work down the page. So it looks to me like we need to use the distributive property first. So remember, we have the given problem. Now we're going to use the distributive property. The distributive property is multiplication over addition or subtraction. So that 4 is going to get distributed through. 4 times 2x is 8x. 4 times -3 is -12. And then we can also combine some like terms over here on the right. We've got a +3 and a -11. So 3 minus 11 is -8 plus 8x. So we just did two steps, one on the left, one on the right, and that's fine. We're just simplifying. So now we need to start thinking about this. We want to get all of our variable expressions on the left, and we want all our constant terms on the right. So let's add 12 to both sides. The 12s cancel on the right because -12 plus 12 is 0. We're using the addition property of equality, also known as the APOE. And so they cancel there, so we get 8x equals -8 plus 12 is 4, 4 plus 8x. And let's stop for just a second and think about this for just a moment. Consider the equal sign. If the equal sign is truly saying that the left-hand side should weigh the same as the right-hand side, it appears to me that this right-hand side is always going to be 4 bigger than the left-hand side. So is this ever going to be weighing the same, the left-hand side, the right-hand side? No. And let's keep going using the addition property of equality one more time. Addition property of equality, or excuse me, not addition property, but subtraction property of equality. Let's subtract 8x from both sides, and we end up with 0x equals 4. Now let's think about this for just a minute, because normally we would divide by 0, but we can't divide by 0. It's impossible to divide by 0. But let's think about this as a question. 0 times what number equals 4? Anything? No. There's no number that will ever make this a true statement. And if we get to the end of an equation and nothing is ever going to make it true, then we say there is no solution. There are no solutions to this particular equation that will ever make it true. Because no matter what we plug in, this side's always going to be 4 bigger. Always, always, always. this side is always going to weigh more. The right-hand side will always weigh more than the left. So there's no solution here. And if there's no solution, then there's nothing to check. Let's look at the last problem on the page. The last problem on the page, negative y minus 8 plus 6y equals negative 9 plus 5y plus 1. So we're going to do the same thing. This is our given equation. And we don't have a distributive property to deal with here, but we are going to combine some like terms on both sides of this equation. So once again, here's our line to focus on as we work down the page, lining up our equal signs here. So negative y plus 6y, those are like terms. Negative 1 plus 6 is positive 5y minus 8 equals. On the other side, there's our 5y. Let's bring it to the front. Negative 9 plus 1 is negative 8. So if you think about the definition of the equal sign, in this case, is the left-hand side ever going to weigh differently than the right-hand side? It doesn't look like it. It looks like they're exactly the same on both sides. But if we keep using properties of equality, we'll see how this all works. So let's use the addition property of equality on both sides, and we will add the 8, which gives us 5y equals 5y. And then if we use the subtraction property of equality, minus 5y minus 5y, we end up with 0 equals 0. And that is a true statement. So up here, we got a false statement because there was nothing we could ever plug in for x that was ever going to make it true. But here, we get a true statement with no variable left. Now, it's easier to look at it if we take into consideration what we had back at this step. 5y minus 8 equaled 5y minus 8. If we were to choose a value to plug in for y, what if we plugged in 1? 5 times 1 minus 8 equals 5 times 1 minus 8. 5 minus 8 equals 5 minus 8. Yes, negative 3 equals negative 3. That's always going to be true. It doesn't matter what we plug in for y, it will always work because of the definition of equality here. So we don't just leave it with true, we say that there are infinitely many solutions. So this is just a quick primer of how your homework should look for Algebra 1. So just reiterating your name, the block, the date, title it, fold it down the middle vertically, giving yourselves 2 columns to do your homework. When we're solving equations, line up your equal signs, and we are always going to work down the page every single time on every single problem.